Hi, it's Moser with a quick tutorial, helps and hints, I guess, on your 4C worksheet. This is number 5 from the 4C worksheet. And we have a very steep railroad track with an angle of 5.2 above the horizontal. We're told that a train has wheels locked and held in place with blocks, but despite all that, is sliding down the track with constant velocity. And we want to be able to find the coefficient of kinetic friction between the wheel and the track. As always, you have to understand the situation, so you got to start with a free body diagram. And we've got this here with a 5.2 degree angle. We have force of gravity pointing directly towards the center of the Earth, which can be divided into two vectors, the FGY and FGX. We have normal force perpendicular to the surface, and the force of kinetic friction, which opposes the object's motion down the slope. Now, with all of these kind of questions, you have to remember that you've got three equations to work with. You have your mu k equals Fk over Fn. You've got your sum of forces on the x and your sum of forces on the y. Since we're interested in mu k, we probably want to use that and find expressions for Fk and Fn. So let's start with our sum of forces on the y. We know it's equal to 0 since this is not spontaneously rising or falling, levitating into the air or sinking down below the surface. And we know that the forces on the y are normal force and FGY, which means that Fn equals Fg times cosine theta, and therefore Fn equals mg cosine theta. On the x-axis, our sum of forces is also 0, because the object is moving down the slope with constant velocity. So that gets us sum of forces equals Fk minus Fgx. Fk equals Fg sine theta. So Fk actually is equal to mg sine theta. Well, at this point, hey, look at that. You have an expression that you can sub in here. You have an expression that you can sub in there. If you substitute those in and trust the algebra, you'll find that you're quite able to solve this despite not knowing the mass of the object or really having a whole lot of information. Happy calculating!